Thank you very much. Very happy for an opportunity to talk to you. Thanks for inviting me. I've been trying for quite a while to get a little bit of the community here in Hong Kong and the region to do more about these topics and to discuss these more for reasons that I still don't understand. There's not much of a community that does open science and cares about this issue. So I hope that here we can kickstart some kind of a discussion, debate, perhaps a group of people who care about these topics and can drive the psychological science forward in all sorts of ways. We have a small team, mainly at HKU, that we're hoping to expand. So if anybody at any point is interested in joining us or collaborating or doing something beyond looking at these issues, both with open science and in meta science, then I'm very happy to talk to you more. I'll provide more links later on and during the talk. If you want, all the slides are available for you to download. You can also scan this barcode and download everything. And also, when we later distribute the video, I'll share all the slides. So a lot of links, a lot of hidden slides that I won't have time to go into. So at any time, you're welcome to download, click all the links. First link that comes up is that almost every talk that I do on open science, and I've done quite a few of those in the last 2 years, I upload to YouTube, and this too hopefully will be uploaded to YouTube. So if you want more content about these topics, I will touch very briefly on each one of the issues, but we have up to 3 hours and a whole semester of me discussing these issues with students and the entire global community of open science movement. I feel like it's important to start every talk, not just this talk, with this slide. Today, I'm going to be sharing with you case studies. It's going to be a very story-based kind of presentation, but most of the stories that I will share with you have to do with social psychology. This is the Association for Social Psychology and a Journal of Social Psychology. But I want to make it very clear that even though things started with social psychology, quite proud to say is kind of like the first that brought these things up. This is not a social psychology issue. It's not even a psychology issue. This is a science issue. So since we started doing all these mass replication efforts and looking at all the issues in science, other sciences have followed up. And as you can see here from some of the headlines that I've been trying to collect from different disciplines, we have major issues in medicine, we have major issues in chemical research, economics followed up, very disturbing findings recently from cancer research, so this ties with medicine. But even with the exact sciences that are closer as possible to math, with empirical computer science and quantum computing and physics, we still see these things come up. So even though the case studies that I will share are based on social psychology, we have similar case studies that expand beyond psychology into the other sciences. Just to demonstrate that this is indeed the case, Nature created a survey and asked scientists from across the field, not just psychologists, whether they believe that there's some kind of a science crisis. And yes, about 50% believe that there's a significant crisis. Whether this is a crisis or not, it's kind of like a loaded term, and we need to be a little bit careful when using such extreme words, but at least, significant crisis or a slight crisis, there seems to be something going on over here with a few that don't know what to make of this, and 3% that believe that there's absolutely nothing going on. So I'm one of the people who see themselves as in this group, that there is something going on and we need to pay attention to this, and I'll explain why. My basic argument is that we are in need of a science reform. We need a credibility revolution. We need to revisit, reassess, and understand what's going on with science. And we should always strive to do better and improve. There are all sorts of ways by which we can improve, the ways that I set for myself. And that's a whole other presentation that I give in the other talks. is that I emphasize collaboration. So we have this big team of mostly early career researchers from around the world that does together replications and extensions and meta science. And I do believe that students and early career researchers are the key for change, because all of us have been kind of like, we grew up in this system, we've been brainwashed a certain way of doing science. And whenever we need to rethink the way that we're doing things, it helps that we have these eager young minds that haven't been tainted by this system in order to really drive and make a difference. So I'm inspired by these early career researchers and these students. And many of the things that I will share with you actually started by students and early career researchers that have highlighted the need for the science reform. I think if we try and kind of historically see what were the first signs of something is wrong, this is actually not from psychology. This is, John Ioannidis. He's a big name in medicine and health research. If you want to know impact or who this person is and you're not familiar with him, usually we go to Google Scholar and we have a look at the H index or the I10 index. So more than 1,000 publications with 10 citations. So we're not talking about a nobody, like somebody like me that you may not have heard of. John is a big name. And in 2005, he came out with this big controversial statement of why most published research findings are false. So a lot of simulations and all sorts of explanations of what's going on. But back then we didn't really understand where this is going. A lot of people dismissed this as it's kind of anecdotal. It's like a nice demonstration, but we didn't really do much about it. Only in 2011, and I'll talk a little bit later what triggered everything in 2011, we started doing replications. It took us about 4 years to do a mapping of all sorts of things in social psychology. And in 2015, 2016, we got our first kind of findings that a lot of things that we consider to be classics in the literature, stuff that we publish books on, things that we communicate on TED Talks, things that we put in every social psychology book, and we communicate this to our students, we tell this to the practitioners. Many of these findings fail to replicate, which is our perhaps most, in terms of the scientific process, this is how we want to ensure that findings are trustworthy, reliable, consistent, that they really hold up for scientific rigor. So having external labs, many labs from around the world try and replicate something. If it doesn't replicate, that's a sign of trouble. So a few famous studies, perhaps you've heard about some of these. So power posing will make you bolder, getting some confidence while taking this power pose. The Wonder Woman pose. Things about embodiment. So if you get the face to frown or smile, if you put a pen in a certain way on the face, then it leads to all sorts of changes in the evaluation of, let's say, cartoons, how funny, humorous, and all that. And then ego depletion, I'm going to talk a bit about this later, and elderly priming, all the priming literature. So ego depletion and elderly priming is two big findings that we entire literatures that we can't seem to replicate very well. So we learned how to work together as a community. Social psychologists from around the world started to do mass replication efforts. And I think that the biggest wave came from 2015, the Science paper. Social psychologists don't publish in Science very much, but this made it to Science, where we tried to replicate 100 classic findings from psychological science, JPSP, so big journals in social psychology. 2018, we tried to do this with social science experiments that were published in Science and Nature. So not even just the psychology literature, but supposedly meeting the highest standards of scientific rigor overall across the sciences. And when we try to summarize all these attempts, so we have many labs 1, many labs 2, this science collaboration, and also these attempts to replicate published findings in Science and Nature, we get to this conclusion that it's about 90 out of 190 in terms of successful replications, about 47%. And in those 47%, the effect size, the impact of the intervention is about half of what we typically expect. And we did this in all sorts of some big effort. Just many labs too is 186 authors from 36 nations, many participants, a lot of findings. And the results for us were very, very disappointing because they really took what is considered to be top of the field, the best journals, the best researchers, the most credible findings. So if we get only half of them to replicate, and in these the effect is about half of what we expect, then it seems like we have a bit of a problem. So we started to do a lot of these. This is just an example of all the things that were published in Perspectives of Psychological Science, or Advanced Methods and Practices of Psychological Science, so two big journals in our field in psychological science. So we can see kind of like a trend here. So commitment priming, honesty priming, hostility priming. I'll come back to the priming literature later, but seems like a lot of failed replication with mass collaboration from a lot of labs from around the world. My summary of the situation before I go into individual case studies, and we can talk about these numbers and what these mean, is that at least in social psychology, our replication rate is somewhere between 30% and 50%, which I think is lower than what most of us expected. That means that, you know, when I came in to teach at HKU and they gave me this book and said you should communicate this to your students, this is the social psychology textbook, and I flip through the book, it's almost 2 out of 3 that I don't think hold anymore. I don't trust these findings. I don't want to communicate these to my students. And even when there is something that I do trust, then it's really overclaiming, overblown, and we need to understand that effect sizes just in the lab are about half of the original. But then, of course, when we go into the field, it gets even worse. Some initial findings, we don't know a lot about what's happening in the other sciences. The biggest project comes from cancer biology, but the little that we do know about what's happening in the hard sciences, the exact sciences, is that it's really not looking very good. And this has a lot to do with all sorts of issues. Of course, there's the systematic biases, publication bias, and how we review and all that. But I think an additional challenge for the exact sciences, especially when it comes to medicine, is very, very small samples. So if we want to run some stuff, let's say a survey, we can get samples nowadays. You can do on MTurk and Prolific, you can do thousands of participants quite easily. But if you do a neuroscience project, it's going to be very, very costly and very difficult to get people into the lab. If you're talking about cancer patients, you know, just getting to that population and getting their their approval to participate and all the risks that are associated with this, very, very small samples. And this leads to a very low rate of replicability. In cancer biology, they wanted initially to start with 50. They were only able to start with 18 because 32, they weren't even able to understand what the procedure was and how to reproduce the materials in order to try again. And out of the 18, it's looking very bad. So the replication rate of that is about half. So overall, we summarize this is about 24%. So social psychology at the beginning we thought was, okay, a weak science, maybe not even a science, a blah blah science, and that's why it's so low. Now we understand that actually social psychology is among the highest replication rates when we compare this to some of the other sciences and the issues that they have in their fields. And I think it increases even more when you have incentives like pharmaceutical companies or big money that's involved in order to get back the investment on what it is that you put into it. So in social psychology, if we don't replicate, I don't know, power posing, not much harm done. But if we don't replicate things in cancer, biology, medicine, people get hurt and people die. So this is a big issue, something for us to think about. So this is kind of like the full. I got this from Twitter. It's not from too long ago, like May 17. So you can see some of the conclusions. So in 2013, they embarked on 50. It took them a very, very long time. They could only start with a few, and then the final replication rate is very, very low and disappointing for us. Common reactions that I usually get, this was like a very brief initial kind of start to the whole thing, is that don't worry, this is just psychology. We never expected much from psychology, and we need to understand that this is not psychology. This is a general science problem. Some people say this doesn't affect me. So if you enjoy the benefits of science and rely on science, especially during a pandemic and COVID, and you are a scientist, obviously this does affect you, and this is something that you should care about. Sometimes I get the reactions like, I know that my research is solid and my research replicates. And my question to you is, how do you know? Have you tried, other external people to go and replicate your work? Sometimes there are all sorts of inherent biases where we convince ourselves of something that's happening even though it's not there. And I think conspiracy theories and all sorts of things are happening with COVID kind of exemplify this very well. But we're not immune to these biases. We study these biases, but these things also happen to us, and I'll give some examples afterwards. Perhaps if there are hundreds of publications, then this means that this is true. I'm going to give you some examples that this is not the case. And some people say, I replicated this, so I know that this works. I've done it again and again, and unfortunately, this is not good enough. This does not mean that something is solid. So I'm going to start with the famous case study that started everything, at least in social psychology. It took a while from 2005, John Ioannidis, for us to wake up as social psychologists and understand that there's a problem. A very famous JPSP paper, 2011. JPSP is a top journal. I think a lot of us are aiming to publish in this and hoping, and this is something that can change careers. Daryl Bem, a very well-known social psychologist from Cornell University, I think the third author in the textbook for social psychology that we used to teach our students. And in this very famous case study by now, he reports 9 experiments with over 1,000 participants using our best practices in our field that show that people can feel the future. So people react in advance to something that's happening, milliseconds or up to a second into the future. So we know that this is impossible based on our understanding of the universe, and physicists have been at it for a while. How could it be that a social psychologist is able to demonstrate something that physicists and goes against our basic understanding of how the universe operates? And when we look at the evidence, we can't make sense of how he did this. So nothing is wrong. There's no fraud here. He didn't make up the data. He used our best practices statistics, but it seems to be solid, which is why it was published, an editorial decision to publish this at JPSP, even though we understand that this is impossible, implausible. So we try to understand, could it be that we found something in social psychology that physicists couldn't do? But when we tried to replicate this, obviously we couldn't, and other people used larger samples, and we repeated this many, many times. There's a whole book that now deals with this thing that came out by Stuart Ritchie, Science Fictions, that I strongly recommend, about how he started with this journey and the replication of feeling the future. A lot of problems here. What can explain this sort of thing? I'm going to give you another case study, and this case study is about the association between eating chocolate and weight loss. So we all were hoping for these headlines that tell us that in order to lose weight, all we need to do is eat more chocolate. So has the world gone cocoa? Eating chocolate can help you lose weight. Chocolate accelerates weight loss. This is terrific news for all of us. Obviously, there are some problems here. What is the problem? In 2015, the person who did this research, which is a real research, he really collected data, he really analyzed this data, wrote this blog post: I fooled millions into thinking chocolate can help weight loss. Here's how. And here's a dirty little science secret. I think we all know and understand this secret. If you measure a large number of things about a small number of people, you're almost guaranteed to get a statistically significant result. So we really put a lot of emphasis on this p-value lower than 0.05. Once we have this p-value below 0.05, we think, okay, we found evidence to reject the null hypothesis. Therefore, we go for the alternative, and we conclude that something worked. Now, what is this recipe for a false positive, for getting this statistically significant results, even if they're not there? Is that what he did is our study included 18 different measurements: weight, cholesterol, sodium, blood, protein level, sleep quality. So if you take a large number of variables and let's say you plot a correlations table, or in this case, you measure this as a DV, just by the randomness of the universe, some of it is going to come out as significant, especially if you use very small samples, as many of us did back in 2011. You didn't need very large samples. There used to be like 15 per condition, 20 at best if you wanted to go beyond that. But all this, 15 people, 18 different measurements, plus, of course, one subject was dropped because of all sorts of, post hoc reasons. But this is a design, study design recipe for false positive. Now, how do I know that this is related to what BEM was doing? Well, BEM gave a lot of advice to early career researchers and people on how to publish articles. So we can just go and look at what it is that he wrote. And this is, for example, some of what he wrote about planning your article. Which article should you write? 2 possible articles that you can write: the article that you plan to write when you designed your study, or the article that makes the most sense now that you've seen the results. And psychology is more exciting than that. Before writing your article, you really need to analyze your data. You need to go deep until you find your p-value lower than 0.05. And then this is what you communicate without explaining how you got there, without pre-registering. Post hoc, you can do a lot of things after you've looked at the data. So you can write what it is that you've designed, and you can write the things that make the most sense now that you've seen the results. And Daryl Bem says, these are rarely the same, and the correct answer is B. The correct answer is not B. The correct answer is definitely A. And when somebody of that, impact writes something like that, it's very disturbing. But this was back in the day where we were all kind of naive, the 2010s. But unfortunately, this is still coming out. So this is from 2018, a Harvard professor writing advice, a point of view: tell me a story, the whole truth. So in presenting your results, you have to tell the truth and nothing but the truth. So far, sounds okay. What you don't have to do is tell the whole truth. In other words, you can select the results you present. So you really can't. This is not science. And the nice thing about eLife over here is that people can write commentary on this, and I like this commentary: selective reporting strongly biases our understanding of the way that the universe works and borders on scientific misconduct. So we really need to be very, very open about everything that we do, how we came to our conclusions, all the exclusions, all the decisions that we've done on how we created things. And I wanted to share a little bit with you about how what we now call questionable research practices, how this thing works. I'm going to show you a Shiny app very, very briefly. I have longer demonstrations, and as you can see over here, we have 4 different simulations. I'm only going to show you one of those, which is a Shiny app that runs on R. It's this one over here. It says P-Hacker, train your P-hacking skills. And I'm going to show you that based on actually just randomized simulated data that shouldn't show any effect, p-values lower than 0.05 are very, very possible. So here, for example, I'm going to use, let's say, and then how many participants in each group. We're going to keep this very small, like 20 in each condition. The true effect should be 0. So everything that I'm going to show you here is absolutely noise. It's random data. Just like the chocolate study, I'm going to increase the number of DVs to 10, and then I'm going to run this. I'm going to simulate this by running a new experiment. And the nice thing about this simulation is that it gives me already all the p-values. So it randomizes, 20 per condition, and it does a t-test ANOVA, and it gives me already the p-value. So the overall n is 40 because of 20 per condition, and we have 10 DVs. So we have DV1, DV2, and all the way to DV10. Already you can see just by me simulating this, and this is supposed to be a 0 effect, that you already have DV number 7 that shows p-value, what we sometimes referred to back then as marginally significant, p-value 0.085. And if we go over here, it already plots DV number 7 for me. So if I look at this And I look at this plot, and then suddenly, after looking at the data, I remember that actually this participant here wasn't feeling very well that day. So I'm going to take this one out. And when I go in, I have DV7, that's a p-value lower than 0.05. So already I can, submit this to JPSP, Science, Nature, and perhaps get everything in there without having to say that I had 10 DVs. I just, shared DV number 7. And nobody will ever know because I haven't shared anything about my study. Nobody knows that there are 9 other DVs. But let's say that I don't want to play with this, with outliers. So let's bring this person back in. There are other ways of looking at this. So BEM didn't do this. He didn't remove outliers. But what he probably did is we go into this tab called Now PHAC. And we're going to add 10 participants. I'm going to click this many times, this tab over here, we're adding 10 new participants. And now you will see something that's called the dance of the p-values. P-values go up, they go down, randomness of the universe creates all sorts of interesting effects. And I want you to see what happens with DV number 7. So if I click this once, you can see DV number 7 is no longer significant. But I do want to publish in Science and Nature. So what can I do without removing outliers? I'm going to keep adding, and I just want you to see what's happening with these p-values. They go up, they go down. It's now DV number 1 seems very promising, but I'll keep going until something comes up. This is getting really close now, so 0.06. Almost. Perhaps in some journals I can round this up to 0.05 and maybe get this to publication. I keep adding. I'm already at 220. Now DV number 9 seems promising, getting close to significance. I'm going to add a little bit more. And just by adding participants, so I add participants, I peak. I add participants, I peak. I arrived at, after 240 participants, I arrived at a DV number 9 that already has a p-value that's lower than 0.05. So success. I can submit my paper to the journal. I can stop here. Nobody's forcing me to run this again or keep going. I arrived at what I wanted, and I can come up with all sorts of reasons of why DV number 9 is the right DV to go. Now, let's say that science requires 2 DVs. It doesn't like just 1 DV. So I'm going to keep going with this. I'm just going to add 10 more to see what happens. It's even, looking even lower than that. So I'm going to keep going. And just by keep going, now I have DV number 7 and DV number 9. So I have 2 significant findings, and now I can finally publish in Science and Nature. Even then, I can make this even stronger by controlling for age, gender, and interaction, and see what happens. And now you can see, 2 more are getting close to significance. So if we analyze the data, just like the advice by BEM, and we don't disclose on what DVs we have and did we peak and what happened, then finally, we can get anything just by the randomness of the universe to show up as significant. And that's a real problem for us. If you want to see other amazing demonstrations of how to p-hack personality, or things about how Republicans and Democrats view the world very, very differently, same data set, but coming to completely opposite conclusions, then go for the other ones. And if you want, you can have a look at my courses to see what that looks like. So are people really doing this? Are people really following this advice? How do we know? We can ask them. So we can have a look at self-admission. This is a paper from 2012 where we ask people, can you please tell us, are you doing these things? So failing to report all dependent measures, how many people are doing this? 78% are saying that this is what they're doing. When we ask them, not you, somebody around you, do you think this is happening? 100% with an adjustment, that some calculation that they did over there. Failing to report all the conditions, 42. Selectively reporting studies that worked, 67%. I think this is very disturbing, falsifying data. So maybe other things we can convince ourselves that this is best practices. Perhaps this is how we've been trained in our PhDs in the 2000s. But falsifying data, it's very clear that there's no way of self-justifying this. So very disturbing that these are the rates that we see in just self-admission, just how people are. And I think the actual numbers are probably higher than this. Any other evidence? now we have other evidence. So we do meta-scientific research that tries to aggregate entire literature. So looking at all the test results across a lot of articles. And typically when we look at effects, the way that the distribution of effects of p-values should happen when we have effects, when the effect is not zero, is that, most of the p-values should be lower than 0.01, and we see a lot of those over here, a little bit less than that, 0.02, a little bit less than that, 0.03, a little bit less than that, 0.04, and a little bit less than that, 0.05. But in 0.05, we see this huge spike in 0.05 findings, which means that if this is there and it's not supposed to be there, people are kind of like pushing, just getting their findings to go just below 0.05. How to get there if it's not fraud? Doing all these questionable research practices by, doing all sorts of things without sharing what it is that people are doing. To summarize the BEM case study, first of all, we have implausible, impossible effects about feeling the future using our best practices. Something is very wrong. There's no transparency about the process. So BEM didn't share that he peaked every once in a while and he kept going until he found support. And what we now call questionable research practices, very common and standard in 2011, 2012. And I think we can claim ignorance. Perhaps we didn't know. Now we know better. But we have meta-scientific evidence, and we have even self-admission reports from this year, 2021. A decade later, after we know of all these issues, we should really know better, but it's still happening, and we haven't done a good enough job to communicate these things. And unfortunately, I think it's great that the Asian Journal of Social Psychology is going towards asking researchers to open up, but I really think that we should make this mandatory. If this is science and we want to be able to check, reassess, verify, this should be mandatory, unless, of course, there are some issues with data protection, and then we have ways of overcoming this and addressing this. But at least by default, everything should be open, and we should share and be open about everything that we do, all the decisions in everything that we've done when we conducted the study. Moving on to ego depletion. Ego depletion, perhaps one of, at least in my mind, one of the strongest findings in social psychology, following, some disappointments from self-esteem and then intelligence and all sorts of things that we thought were the big kind of message that social psychology has for the world. But then self-control seemed to be willpower, something that's very important and a predictor of a lot of things. And then came the idea of ego depletion, that self-control is a bit like a muscle. You can train it, you can enhance it. And then when you use it, just like when going to the gym, you use, and then you have some fatigue. So if you do self-control task in one domain, and then you go to a different domain, just the fact that you exerted some self-control in the first domain is going to decrease your ability to exert self-control in a different domain. How impactful is it? Very, very impactful. So these are the main findings from 1998. So this has been going on for a while. You can see 6,000, 5,000 citations, lots of reviews from the 2000s, 3,000, 1,500. And the most, I think, promising, so when I was doing my PhD for 2010, there was a meta-analysis, and we love meta-analysis because it summarizes an entire literature. And we came to the conclusion that the Cohen's d of 0.62, so terrific. And that means that we have a solid medium effect ego depletion sort of phenomenon, and that we can, start communicating this to everybody and tell them about this big message that we have about how to overcome ego depletion and increase their willpower to help them in all sorts of things in their lives. The issue is that since the 2010, given everything that's been happening in social psychology, people said perhaps we have some issues with publication bias. And given that we don't know, all the literature that we have, everything is positive findings. There's no null findings. The only way for us to really know if something works, given a publication bias, is to just repeat this again with mass replication efforts, or replication registered report. So you can see Hager over here. This is the same Hager that did the meta-analysis. So the person who did the meta-analysis, definitely one that's very invested and believes and has done research on ego depletion, is the same person who is actually doing the ego depletion mass replication efforts. Big names over here, many of them have been doing ego depletion for a very long time, for years, have done this mass replication effort. And as you can see over here, 23 labs, over 2,000 participants, different places around the world. What is the conclusion? The conclusion is this, Cohen's d of 0.04. So definitely not even close to 0.62 that was in the original. So for example, this one study that they originally looked at had the Cohen's d of 0.68. But if you look at all the labs, if you can read this forest plot, you can see that most of the confidence intervals overlap with the null. There is one that doesn't overlap with the null that goes in the opposite direction, one that doesn't overlap that goes in the same direction. But overall, when you summarize the whole thing, and it's this diamond over here at the end, the Cohen's d is 0.04 with, of course, confidence intervals that overlap with the null. So a failed replication by any account. Michael Inslet, you can see his name over here. He was part of this team over here that did this. He is a person who is, has been an ego depletion, willpower, self-control researcher for a very long time. This is what he wrote in his blog following his tweet of RRR of ego depletion reveals no effect, nada, zip, nothing. I have spent nearly a decade working on the concept of ego depletion. I have been rewarded for this work. I'm convinced that the main reason why I get any invitations to speak at brown bags and conferences is because of this work. And now, after a decade of him doing and publishing on this, he writes, the problem is that ego depletion might not even be a thing. So how can it be that somebody who's been doing research on something and publishing on something for over a decade, because of a mass replication effort, now is saying that perhaps ego depletion is not even a thing? And this is what he wrote, and I remember this as a postdoc in 2016 reading this, breaks my heart to read this kind of thing. Sometimes I wonder if I should be fixing myself more to drink. It means alcohol, of course. I'm in a dark place. I feel like the ground is moving from underneath me, and I no longer know what is real and what is not. So this mass replication effort, it's a big deal because it's making social psychologists like Michael consider drowning themselves in booze and leaving the profession. And the main summary here is that we had no idea how wrong we could be. And we've been doing this for a very long time. This started in 1998. Now, the initial reaction from the folks that started ego depletion was a little bit negative, misguided effort with elusive implications. So you didn't choose the right effect, you didn't do this correctly, you asked us for our opinion, but we didn't pay too much attention to this, but you didn't know what you were doing. But we now take responsibility. We will show you that ego depletion is going to work. So this is what they wrote. We will organize a pre-registered multi-site replication project next year using well-tested procedures, not the ones that you chose. And we pre-registered the hypothesis that ego depletion, of course, it works. Thousands of citations, hundreds of articles, of course it does. Unfortunately, we waited patiently 2 years. And when Kathleen Voss finally came out, this is now in Psychological Science, this is their conclusion. We conducted a pre-registered multi-laboratory project with 36 labs from around the world, so larger than the previous one, not just null hypothesis significance testing, but also Bayesian and all sorts of other things. What is the Cohen's d? Cohen's d is 0.06. So the original authors who first pushed back on this but took responsibility, they came up with a very similar conclusions using what they consider to be best methods and practices. Over here you can look at this plot. It's just like goes in all directions and everything overlaps with the null. So this is the conclusion. It's a very disappointing conclusion for us. So the summary of this attempt is that we have 2 big labs. The second one is by the original authors coming from around the world, 23 labs plus 36 labs, really very big investment to try and understand what's happening with ego depletion. But if the effect is 0.06, so if you understand correlations better, it's like a correlation of 0.03. In order to run a study and detect anything, now that we know how to do a power analysis, if we aim for power of 80, you need almost 5,000 participants to study this. Even if this is an effect, and I don't think this is an effect, but even if this is an effect, it's not a meaningful effect, and we can't really study this. So we really need to invest our resources in something else. So to me, and to Michael, and to a lot of people who have been doing ego depletion, this is really the end of ego depletion. So this is a summary of everything that's been happening with ego depletion. We started from this. This is the meta-analysis. Then we found all sorts of publication bias adjustments to our meta-analysis, and this brought us closer to zero, which is why we started doing replications. And now we understand that we're somewhere very close to zero. But this just shows you the confusion about ego depletion and how from 2010, a decade later, we now went from this is a good solid medium effect to now this is not something that we should study and invest our time in. You don't need to just take my word for it. You can go and listen to Michael. He has a podcast and it's highly recommended. Two Psychologists, 4 Beers, and he talks about his journey with ego depletion and really heartbreaking stuff. Listening to them talk about this, it's difficult. So I strongly recommend that you do this. I play this to my students. I think it's very important, which is why I really appreciate that the editors of the journal, Asian Journal of Social Psychology, are opening up, their discussions about papers, because we need to understand how top social psychologists and editors in our field are thinking about all sorts of things, what, their perspective, how they're looking at information, data, article scholars. So I strongly recommend first go and listen to this and then look up other podcasts like the ones by the editors of Asian Journal of Social Psychology and really get some insights from leaders in the field and how they feel about issues of open science. Once again, a summary: no systematic replications up until 2010 when Hager, after his meta-analysis, decided to do this. Very strong indications of publication bias, which is probably what's explaining how we got this ego depletion in hundreds of articles, and now we understand that ego depletion is not a meaningful effect for us to study. And also, I think it's we need some humility. So the initial reactions were negative and skeptical. The original authors pushed back on this, but they took responsibility. So whenever somebody replicates your work, I think a good reaction is, thank you for sharing this with us. This is good evidence. We need to take this into consideration. Let's work together to figure this out, rather than, replicators are out to get us or anything like that. As a scientific process, as a scientific community, we need to work with one another in order to make sense of what's happening to us over here. I think this case study is really important to establishing that. Last thing that I'm going to talk about is priming. Some of it is a little bit related to us because one person is or was based in Hong Kong, and I got to be in the same university with him. So Through and Wire, classic 1979. We know that hostility priming, if you unscramble sentences and you do all sorts of things, this primes, activates all sorts of things in your mind. Very large number of citations, very impactful, has led to all sorts of things. You can see the citation over the year just increases with impact every time. And a lot of foundational work is built on this, including some of the activations and the manipulations. And when we did finally in 2018, we decided to go back and look at this. And the protocol was vetted by Robert Wire over here, is that although the confidence interval for one outcome excluded 0 and the observed effect was in the predicted direction, these results really suggest that the currently used methods are not, do not produce a priming effect that can be practically and routinely detectable. So a failed replication of Through and Wire. So why do I need to show you another case study of another thing that didn't work out? Because we could have known this even without the replication. How could we have known this? If you look at the meta-analysis looking at Through and Wire, you can see that they ran this on 80 participants. And what is the effect size? A Cohen's d of 5.65. a Cohen's d of 5.65. This is an impossible effect. When you look at the ANOVA, the F statistics, it equals 123.74. So if you compare this to like what is the Cohen's d of that magnitude, it's kind of like the average, you know, if Shaquille O'Neal, who was a big name during my time, was kind of like comparing this to the average female. So a very, very visibly large effect, which is absolutely impossible here. And Bob Wire actually hints that this is an error in reported statistics. There was an error in there, implausible, impossible statistics that we failed to notice from 1979 until the 2010 18, when Randy came along and did the mass replication effort. We didn't notice this. We need a, you know, even in the meta-analysis, they included this among everything else. And I don't want to, you know, all this Stapel stuff. Diederik Stapel is the person who did priming literature and was came out as a fraud in 2011. So everything about this meta-analysis of the priming literature, starting from really errors in reporting plus a lot of fraud here, really shows a big problem in the priming literature. Plus a four-way interaction looking at p-value just below 0.05 and 0.02. I don't, you know, it's hard for me to capture a two-way interaction. Capturing a four-way interaction, saying that you hypothesize this in advance using 8 participants per cell, and look at these figures, just like perfect. So it can't be, you know, the randomness of the universe and noise and very, very small samples cannot produce this kinds of nice figures. So you can see it's kind of like the Twitter discussion of this sort of thing. Did you look at the figure? So this is Brian Nosek from the Center of Open Science, the founder of, you know, some of the big collaborations. Man, the conclusion is a lot of our literature has just findings that are just too perfect. They're impossible. And when we looked at the replication effort, we again found overlaps with the null, so there is no effect. It's impossible to get the effect that they reported. So finally, can't really rely on this. We can't seem to replicate this, a big problem. Some people came and said, they can't be, you know, thousands of citations, hundreds of articles on priming, something must be in there. Maybe it's because the words that you used in 1979 are not up to date and you should do a conceptual update on this. So they did this again, once again, another mass replication effort. And they said, not just a direct replication, let's do another conceptual replication, really best effort to try and find something with this priming, unscramble sentences for hostile. And we can't get this to work. Despite our best efforts to produce favorable conditions for the effect to emerge, we did not detect a hostile priming effect. Can you imagine Randy and all the people, so many labs, so many people, you know, millions of dollars invested in this altogether to try and counter the original one, and the original one is still out there. So no one noticed for decades that there are obvious errors in reporting, that there are impossible effect sizes, the figures are just too perfect. And science is not self-correcting, because even after we know about all these things, nobody retracted that paper, nobody corrected the error. The error is still there, it's still been cited more than the replications. Big problems for us. I won't go into all the rest. There are some big problems with John Barge and elderly priming, a lot of issues in there. I was going to kind of demonstrate this, but we don't have a lot of time. So I'm not going to go into this in too much detail. Let me just check something. Yeah, so I'm gonna leave the John Barge issue aside for now, but I am going to say that we now understand that his findings just have, you know, first of all, very small samples, you know, 15 in each condition, yielding consistent effect, which is just, we know, is impossible. And then reporting effect sizes of Cohen's d of 0.8 and 1, which we now understand is a big problem. And it's not just me saying this and falling into this trap, but also Kahneman, you know, the only psychologist to ever win the Nobel Prize, that fell into this trap. And he's the one that, after the failed replication, the first failed replication of John Barge's elderly priming and all that, wrote an email really asking or begging everybody, please make sure that everything is solid, because I can see a train wreck looming. And the only thing that he had invested in this is that he has a very enthusiastic chapter in his Thinking Fast and Slow about priming, which nothing in this seems to hold. And it's especially ironic because in a blog comment that he wrote, there's a special irony in my mistake of trusting priming research based on very, very small samples and very large effects, because the first paper that Amos Tversky and Daniel Kahneman wrote in 1969 and published in 1971 was about the belief in small numbers. He went to statistician conferences and he showed that even statisticians fall into the trap of trusting findings based on very small samples. So this is what he published, and as you can see, he actually gives the demonstration that looks very, very similar to the findings by John Barge. So if Daniel Kahneman, who warned the world about these biases and how we believe in, these impossible effects, falls into this effect to include this in his own book, Thinking Fast and Slow, of course, all of us can fall into this trap just as much. I would like to show you a demonstration of just how unreliable elderly priming is. We don't have a lot of time, but I just want to show you that in this p-checker, you can include all the p-values from all the published literature. If you go over here, other good souls already included stuff like elderly priming. So if you, Daniel Atkins already included all of this. So you can see all the literature from elderly priming is in here. And first of all, we can do stat check in order to see whether the p-values are correct. So now we have these amazing tools that allow us to see whether, the reported p-values are correct. We can very easily do a meta-analysis to see if there's a publication bias. And if you can read funnel plots, this is a strong indication for publication bias. It also gives us the publication bias tests to show us that elderly priming has a very, very big problem with publication bias. Plus, we have all sorts of tools like p-curve in order to show us that what we see in elderly priming in terms of the p-value is just impossible. So there is no evidential value for this literature. If there is evidential value, it is inadequate, and there is some evidence that this is intensely p-hack. So we can take the published literature, we can put this into these tools in order to see whether these things are solid or not. If you want more information about this, we can talk about that later. Problem is, John Barge, 2018, comes up with a book that has zero acknowledgement of all the replication efforts and everything that has happened since. New York Times bestseller, keeps on going with this. I just don't get this. I can't make sense of this. This doesn't feel like science to me. Really, we should sort these things out. We should learn from our mistakes. We should work together. This is not the way. Last 10 minutes, I'm going to talk a little bit about my takeaways and my conclusions. I don't know what you're taking from the case studies and my very brief summary of the literature and the findings, but even if you don't agree with me that there is a crisis or something is going on, at least, be with me on the message that we are in need of self-reflection, reassessment, and improvement. It's a little bit like this here, the cartoon about global warming and climate change. People are talking about, energy independence, sustainability, green jobs, livable cities, and then somebody yells, what if it's a big hoax and we create a better world from nothing? I think it's the same with open science, with sharing everything, with trying to improve and do better. We're talking about, data sharing, reducing publication bias, preventing p-hacking and questionable research practices, increased transparency. And then occasionally when I give talks about this, somebody says, but what if this is a big hoax and we create a better science for nothing? So let's please create a better science, regardless of whether you believe in we have a crisis or not. If you want to know more about this, I give lots of lectures and tutorials and workshops about how to do things like pre-registrations, how to do things more reproducible with R, everything about open science. So you can look at that. My solutions, this is kind of my overall strategic decision that I decided during my postdoc to put everything that I'm doing aside and just think, what is it that I want my research to look like? It took me about a year to sit down. This is not just my stuff. I took from a lot of different people. But first of all, full transparency. Not just sharing all my materials, my data, and my code, but really the entire process, from having a research question, every decision about all exclusions of conditions and variables, and also aiming for high power, doing register reports. Findings are findings, including the null. So it doesn't matter if p-value is above or below 0.05. We really need to share everything. We have a very large team that does all sorts of things. I'm not going to go into this right now, but if you want the short version, it's here. If you want a longer 3-hour version, it's over here. But basically, we've conducted, over 3 years, we've conducted 100 replications and extensions using, working together with students using the HKU courses in order to look at the judgment and decision-making and social psychology literature to see what is solid and what isn't solid, and creating a lot of tools and resources that you can use in order to implement open science and do replications and extensions with your students and in your universities and departments. The last part that I want to mention very briefly, because we're out of time almost, is about register reports. It's a new concept. I'm very thankful for Chris Chambers, first for the slides, but Chris Chambers is the one that came up with this notion. It started in 2013. It's really the right way to go. Hopefully the Asian Journal of Social Psychology will endorse this if it hasn't already, looking at this as the right solution for science. The big paradox that Chris Chambers is talking about is like, which part of research study do you believe should be beyond your control? We shouldn't control the results, because we should be documenting what it is that is out there, a real phenomena. But when we are evaluated to get jobs, to get into graduate school, then to get a postdoc, then to get a job, then to get promoted, which is the thing that we are evaluated on the most? The results. So there's a big conflict, a big paradox here about, you can't touch the results, but you have to make the results amazing. And you can't have both of these together. So there creates a conflict between what is best for science and what is best for scientists. What is best for science is, having really high quality research published regardless of outcome. But unfortunately, the way that we're incentivized, and everything about the publication system, the promotion system, is about producing a lot of great results. This is unsustainable. We can't have a lot of it's impossible for us to have a literature that's 90% positive findings. This creates a lot of problems. So when we look at the scientific life cycle, from generating hypothesis, designing the study, collecting the data, interpreting, we see problems in each and every step of those. And now we have meta-scientific findings to show us that only 1 in 1,000 papers is being replicated. 999 of 1,000 do not ever get replicated. So how do we know that this is solid? We have very low statistical power, a lot of selective reporting, and now we know questionable research practices. People are doing harking all the time. Plus we have a publication bias and we don't share anything that we do. So all this is wrong. We really need to correct all of this. And how to do all of this correction in one go? Registered reports came in. He did this first in Cortex. And the issue is that the traditional publication system is that if you want to submit to Asian Journal of Social Psychology, you do everything. You design the study, you collect the data, you write the report, and only then you submit this to peer review. And then maybe desk rejected, maybe goes to review, or maybe a few rounds, and then a lot of adjustment, drop the study, do this, add additional analysis, and then probably at some point, hopefully, you'll get a publication. And in many journals, I don't know about Asian Journal of Social Psychology, but you are evaluated on how novel, how exciting, how amazing, how p-value lower than 0.05 your findings are. But this is broken in my humble view. This is the register report model, where you have stage 1 peer review after you design the study, before you collect the data. And what happens over here in the first peer review is we work together with reviewers, authors and reviewers, try to see what is the best method to tackle this? Are the hypotheses well-founded? Are the methods the best method? Is it well-powered? Are there enough sufficient positive controls to make sure that this is really studying what it is that should be studied? And if this is done well, the journal gives you an in-principle acceptance. It means that it doesn't matter what the p-value is. It doesn't matter what the results are. As long as you follow the plan or explain very carefully why you deviated, as long as you did this, it's going to get published. So no more outcome bias, no more hindsight bias, no more p-value dependent publishing. We get to decide whether something is published based on the design, not based on how wonderful the findings are. In the stage 2, the only thing that the authors need to do is check whether the authors followed the protocol or explained very carefully why they deviated and whether this makes sense, and are the conclusions justified by the data. And this takes care of all of the problems and suddenly, for the first time since the beginning of time, we have this clean, green process without all these biases. When I show this to my students, the students are, wait, this is not how science works right now. Like, I'm really sorry. It's not. I don't know how we created this monster of a publication system, but now we have registered reports, so we know how to do things better. I really think like the status quo research right now, the basic slide is from Chris Chambers, but I really think the status quo research right now is barely worth a mention. If it has some open science and everybody is sharing everything and we have some replications, maybe it's of some relevance, but for us to really conclude whether something is solid, reliable, we need mass collaborations, registered reports, and a meta-analysis of many registered reports. I also added these on top. I think that also meta-analyses need to be registered reports, and we need to, not a meta-analysis once in a decade or two, but we need continuously updated registered report, meta-analysis of registered report with everything open data, open code, open search process and all of that. I won't go into this, but we have a lot of evidence that pre-registrations and registered reports really work. A lot of it definitely reduces biases, it increases quality, stops p-hacking. We now have enough meta-scientific evidence to really conclude this. Plus, in terms of methods rigor, quality of methods, amount that we can learn, the quality of the questions, the analysis rigor, big teams came together to do kind of like a randomized control trial of registered reports versus the original one, and registered reports across all domains in all possible things really show an improvement over the previous process. So for me, registered reports are the way to go. There are now over 300 journals that do registered reports, also in psychology and in other fields. So when students work with me, thesis students, I only do registered reports, and it's a very meaningful process. There are some hidden slides where I shared some of the feedback by my students about how meaningful it was for them and how much they've learned from registered reports. And it's really a constructive, positive process where reviewers and authors, rather than going against each other, are working together. And plus, it's also good for your careers. So rejection rates in the journals go down from about 90% in traditional model to about 10% in registered reports, because there's no reason to reject you if we can just work on the methods together and improve those. So everything that's wrong, we can just correct this and get to a point where we're actually measuring what it is that we need. So we're not evaluating you and how well you've designed or analyzed things. We work together in order to really study the phenomena. This is where science should go. This is kind of like a very brief, rushed summary of everything that I had to say about, the status, a bit about registered reports. But we do have a very large project, and we are looking for people to join us. So if this intrigued you and kind of like triggered your curiosity and you want to know more, we have a lot of ways for you to come and join us. We have a lot of projects that are finished that you can come and take lead on. We can collaborate on things. We have over 50 early career researchers from around the world that are working on open science and meta science together. So if you want to learn more about that, just visit this link over here. And This is a link to my webpage that summarizes our mass replication efforts. So if you want to know more about that, just visit this link. Plus, I'm very happy, enthusiastic about helping you do better, especially here. We're all close to each other in Asia, in Hong Kong. So it's easy for us to get together and work on these things. So if you have any question, you want help with anything, we have a lot of resources. You can go on my webpage and look at all the resources that are available. I'm very active on Twitter. There's also a mailing list about all of our workshops, our talks, our resources, our publications. Plus, if you have a specific question, you can really contact me at any time. And either I can help or I can connect you with our team and they'll help you. We're really looking forward to working together with you to implement open science in your universities, in your departments, in your teams, in your journals. So just let us know how we can help you to do better in your science. That's it. Thank you very much.